Okay, internal energy of a system. Internal energy is the total energy contained within a system due to the microscopic motions and interactions of its particles, molecules, atoms, ions. Internal energy is the total energy contained within a system due to the microscopic motions and interactions of its particles. Interatomic interactions of particles. The particles are molecules, atoms, or ions. Or also we can define the energy associated with a system by virtue of its position or its molecular constitution is potential energy. It includes kinetic energy, translational, rotational, vibrational, and potential energy. Kinetic energy and potential energy. Kinetic energy are translational, rotational, vibrational. Potential energy means intermolecular force bonding. Internal energy includes kinetic energy and potential energy. Kinetic energy means translational, rotational, and vibrational energy, and potential energy includes intermolecular force bonding energy. Molecules possess energy by virtue of motion, which is called kinetic energy. Components of internal energy: translational energy, translational kinetic energy of molecules, rotational kinetic energy, vibrational energy, intermolecular potential energy, electronic energy in atoms, molecules. The sum of all possible kinds of energy associated with a system by virtue of its position or motion or both is called internal energy or intrinsic energy and denoted by E or U. The sum of all possible kinds of energy associated with a system by virtue of its position or motion or both is called internal energy or intrinsic energy and denoted by E or U. Some facts on internal energy can be summarized as follows. Total energy equal to internal potential energy and internal kinetic energy. Absolute value of internal energy cannot be measured, but change in internal energy can be measured. Internal energy is the function of temperature, pressure, and volume equal to F TPP. Hence, internal energy is the function of either pressure and volume or temperature and pressure or pressure and temperature mathematically equal to FPV, F equal to FTV equal to FTP. Internal energy is the state function. Its value depends upon its variables, pressure, volume, and temperature only. Its value does not depend upon part, but only depends on initial and final condition. If U1 be the internal energy of a chemical substance under one set of condition and E2 be the internal energy due to change in condition, then the change in internal energy is given by D equal to 0. Internal energy is the extensive property. Its value depends upon the quantity of matter present or fixed quantity of chemical substance under a given set of conditions has fixed value of internal energy. The value of internal energy is different chemical substance. Sign of internal energy change for chemical reaction, delta E equal to E product minus E reactant. If a chemical reaction proceeds by decreasing internal energy, that is the internal energy of a product is lesser than that of the reactant. Some amount of energy is lost due to surrounding and delta E becomes negative. That is delta E equal to EP minus ER. So delta E equal to negative if ER is greater than AP. If a chemical reaction proceeds by increasing internal energy, that is internal energy of product is greater than that of the reactant. Some amount of energy is gained to system and delta E becomes positive. That is delta E equal to EP minus ER. That is delta E is positive if energy of product is greater than energy of reactant. Units of internal energy. Internal energy can be expressed in different units. The SI units is joule or kilojoule and calorie. That is 1 calorie equal to 4.184 joule. Sorry. Experimental determination of internal energy, that is the delta E. The internal energy change during a chemical reaction can be determined by using Bohm calorimeter. In practice, enthalpy change of chemical reaction is measured by using calorimeter. The process of determination of enthalpy change of reaction is known as calorimetry. Calorimeter or calorimetry is related with the unit of heat calorie. Different types of calorimeter may be used in different circumstances, but Bohm calorimeter is used to measure the heat of combustion. Bohm calorimeter was developed by Bartlett in 1881 to measure the heat of combustion of organic compounds. Pretty simple. A calculated amount of chemical substance is taken in a sealed combustion chamber made of or steel provided with internal coating with non-oxidizing matter or gold or platinum. Thus, sealed combustion chamber is known as bomb. When the organic compound is burned by passing electric current, then the amount of heat energy released is measured. According to first law of thermodynamics, dq equal d plus pdv, since volume is constant, dv equal to 0, the expression first becomes dqb equal to d. Since the reaction is carried out at constant volume, no work is being done in calorimeter. In such condition, the heat change of the reaction is equal to the internal energy change of chemical substance. Combustion reactions are exothermic, so delta H has negative value. This is the figure of Bohm calorimeter, uh, stirrer, oxygen gas, ignite wire, sealed bomb, sample in crucible. Compound plus oxygen gives peroxide heat. AT-vol is the heat of combustion at constant volume. AT-vol dQ equal to mass of the substance and specific heat of capacity of calorimeter in rising temperature. We know that dQ equal to dE, so dE equal to ms dt. Process of fixed weight of the chemical substance whose delta is to be found taken in crucible within a steel bomb provided with Q2 under 20 to 30 atmospheric pressure. Okay, okay, sorry. Process of fixed mass of the chemical substance whose change in the internal energy is to be determined is placed in a crucible inside a steel bomb filled with oxygen at a pressure 20 to 30 atm. The steel bomb is lowered into water bath kept in a insulated copper vessel. The vessel is provided with a one stirrer and a thermometer. The whole part is insulated to ensure perfect insulation. The temperature T1 of water bath is noted before the combustion. By passing the electric current, the sample is ignited. After constant stirring, the final temperature T2 is noted when the complete combustion takes place. The increase in temperature is found by the relation delta T equal to T2 minus T1. Okay, thanks for watching and request you all like, comment, share, and subscribe. Thank you for patience. That is now. Bye bye. See you again.